Good afternoon, everyone, and welcome to this session on Telescope, our next gen AI for satellite image segmentation. I'm Michelle Paul, your host, and your speaker for this session is Dr. Paramjeet, the Global Head of AI Practices at Afine. Hi, Param, how are you?
Hello, Nikhil. I'm good. Thank you. How about you?
I'm great too, thanks. Just to give a brief introduction of Param. Param is the author of Quantitative Finance and numerous other research publications. And with his PhD in applied mathematics and decades of data science industry experience, he specializes in solutions that enable a multitude of cross functional initiatives like mentorship, industry academic research, client management, and technical advice. Essentially, he's laying the groundwork for revolutionary transformation among global brands. So, one of these revolutionary products is Telescope, which we'll be deep diving into today. We're all super excited to learn about Telescope, Param. So, let's get started off right way. And
Sure, Nikhil.
to, I know there must be a lot of questions on your minds. So, we'll run through some which we think must be at the top of your minds. Feel free to post any questions you'll have in the chat box, and we'll try to answer as many as we can. So, Param, kicking things off, maybe we can start off with what exactly is Telescope, and what are some of its key highlights.
Yeah. So telescope essentially essentially is Affine's homegrown product, which is trademarked with the government of India. It has also been hosted on the AWS as a SaaS service, right? This product is easily AWS as a SaaS service. So this is primarily designed to solve the complex satellite image segmentation problems using advanced cutting edge deep learning technologies. So primarily it has been designed to identify or to segment various structures over the surface using the satellite images. So the structures that what I mean structures could be anything. Right now what we are offering is basically the it identifies the structures. For example, the structures could be buildings, land, water bodies, vegetation, etc., right? And it has penalty of use cases across industries. So now when we talk about the telescope, so like other products out in the market, this product telescope very specifically designed by keeping certain features in mind. So first of all, this feature is very exhaustive and very generalized in nature. So it can be easily extend to any number of segments, any number of classes. So as I just talked about, that it can help you to identify the land, water bodies, right? Other geographical structures, vegetations, right? It can be easily enhanced to the other very specific structures, right? The another key important feature of this is basically because this is built on top of the deep learning technologies, and this is where the consistency of the model or the accuracy of the model comes into picture, right? So when we talk about the telescope, this has been designed by using the deep learning technologies, and this is very sophisticated, and it precisely identifies or it precisely segments the objects, right? So that is very critical. So in fact, I would say that this product has helped us to one very recently one Amazon hackathon as well, right? So we just day before yesterday we have used this telescope to some extent, and we have won this hackathon. With the agenda of this hackathon was basically to monitor the various water bodies using the satellite images data. And the satellite images that what we got from the Amazon was such a huge, right? So the image size was humongous, and each image was around 300 MBs, right? So the image size was humongous, and this is where we have utilized it to some extent. It has helped. It really helped us to get to a state where we can potentially use this application for other clients as well, right? And another key important feature is this can be easily integrated across platforms, across various data sources. So right now we have by default we have integrated it with the Google API to fetch the data, satellite data, but it is flexible enough to be integrated with the other data sources, the other the other way, I mean, there are other ways as well to fetch to fetch or to integrate the data sources, but by default we are keeping it with the Google API.
Okay.
It also helps you to automate some of the workflows. There are many enterprises who are who are spending months of time basically to automate or to complete some of their core or critical service for their decision making. And this is where, instead of spending the manual effort of months or weeks, this can reduce the time significantly, right? So in some of our engagements that we have seen, that this platform has helped our client to reduce their survey time or reduce their decision making time by close to 60 to 70%, right?
Wow.
So that was a huge benefit,
Right.
and clients were very impressed with the time reduction. uh, and another key benefit, once we reduce the time, obviously it has some cost implications as well, right? So it cost benefits as well. So along with the time reduction, it also helped the client to reduce the development cost by around 40, approximately 40%. So that was a huge benefit on the cost front. And the other key benefit of telescope is it is completely customized, as I mentioned, and it can help you to fetch hundred square kilometer of image, right? So this is something which can be easily configurable, right? So 100 kilometer, you can make it to even more high resolution. Let's say if you want to focus on some specific smaller area, then you can reduce it to maybe 20 square kilometer. So this is completely configurable, right? The
Right.
another So overall, I mean, it helps you to identify some of your workflows, which significantly reduces the timelines as well as the cost, right? So now, as you know, the telescope, I think I will also take you through some of the key, I would say, the key flows that have been used to implement such a sophisticated platform. So I will not get into the details of the deep learning model, how the deep learning technologies work, but I will take you through the high level process flow, that how the flow works. To implement any artificial intelligence or any AI models, right? Could be the computer vision, could be the core machine learning models, or could be any data driven models. You need the data, right? So in this specific case, as I mentioned earlier, we are using the Google APIs to fetch the data. So in this specific case, we use hundreds of images, so more than 1,000 images to to create our bucket of the data set. So we fetched around more than 1,000 images using the Google API. We passed it through the annotation layer. We created some sort of the random shaped labels. It was not just the square bounding boxes. Rather, we created some random shaped labels, and then we also pass it through some sort of the pre-processing layer, followed by the data augmentation. So data augmentation is the technique where basically we play around with the actual image, and we just try to enhance the the data volume, right? So now, when we have the significant volume of data, when we have the significant volume of images, then we basically divide or bifurcate the whole data set into the couple of buckets. So normally these buckets are called as the training, validation, and the test data sets. So data set is used to train the model, right? And here what you can see, that we are using the blend of FPN and the point trend models. So these are the cutting edge deep learning models. So when I say the FPN basically stands for the feature pyramid network. It creates the features of various resolution, and it finally helps you to create some sort of the latent, the lateral features, right? So, and that features have been amended or have been clubbed using the point trend model. So point trend is basically from the Amazon. So this has been used in the Detectron 2 library from Amazon. So the Amazon team has worked extensively on this library, and we are using blend of these two technologies, FPN and the point trend, to get such a sophisticated model, right? So once we have that model in place, right, then the next step is basically to validate its consistency. How well is that model consistent enough to be deployed into production? So to do that, we basically define certain KPIs. The KPIs that what we have used for our analysis, for our model development, was the training as well as the validation loss. So these KPIs are pretty standard. And in most of the application, you will see that people are using the training and validation loss, and we want to minimize that loss, right? So IOU, which is the intersection over union, this is another KPI that we use to check the consistency of the model. So once we have that model in place, normally we check for some certain validations, how consistent or how accurate the model is. If we find that model is consistent enough, we go ahead and we save the model in certain repositories and we deploy it into production. Otherwise, if the model is not consistent, or the KPIs or the accuracy is not decent enough, then again we have to go back. It's more like a feedback loop, right? We have to go back to the training data set, we have to fine tune certain parameters, and we have to identify the root cause, that why it is not giving the desired accuracy, right? So then we have to process the data, we have to play around with the data, play around with the model, and then come back to the model until we get the decent consistency, right? So overall, this is the backend flow. So I will also explain you how the output of these models or output of this flow looks like, right? So these are a couple of images that I would like to you to take you through. So this is the specific location from US. So here, in our platform, normally we have the lat long of the location which we want to analyze. So usually we enter the lat long coordinates, and the moment we enter the lat long coordinates, it uses the Google API in the backend. It fetch the satellite image along with the location, actual location, right? So here on the top, but you can see the location as well. So this location we got from the Google API. So once we get that information, we pass this image to our model, the model which we just saw, the blend of FPN and the point trend. We pass this image to the model, and we get the output on the right hand side. And right hand side here, what you can see, the right hand side, basically the what you can see, the significant portion of that image is greenery, right? And this is what you can see on the top. It has given you the different percentages, that what all structure this image has in terms of the percentages. For example, in this specific case, as you can see, the greenery is approximately 85%, followed by the utilities, right? Whereas the other classes are very minimal. These greenery and the utilities are predominantly present in this image. So this was the image basically taken somewhere outside the city. But I will also take you a glimpse of another image where we are looking at the structures within the city, right? So in this image, again we have passed the lat long coordinates, and here it fetches the image on the left hand side. So once we have that image, again we pass it through the model, and the model, what it depicts, is visible on the right hand side, right? So here what you can see, that it identifies that 33% of the image consists of the buildings, followed by the 30% are the utilities. So utilities, as I mentioned earlier, are like the railway tracks, the roads, and all, right? So there can be the various parameters in utilities, and it identifies the significant portion is utilities, right? So the third significant class is the soil and the greenery, right? So this is how the output of this application, how the output of this platform looks like, right? So this platform also has certain other features, in terms of the different visualizations, how you can visualize your data, right? How you can share different access to the people, right? But I think that is something that we can explore over, we can explore further. But I think at very high level, this was what the telescope is.
Right.
Yeah.
Right. So thank you for that very uh, overview, for that complete explanation of how or demoing to us how telescope works, and what are the functionalities. So now, Param, you mentioned that telescope gives like 70% reduction in planning time or 40% reduction in cost. And for those of us who want to know, maybe could you shed some light on the AI which makes telescope give us all these amazing statistics?
Yeah. So correct. So I would say this this is very critical questions. So as we are talking about an application, right, which is very
Right.
sophisticated or data driven, so it becomes very essential to understand the backbone of this application, right? How this has been designed, right? So now to answer your question, so this has been designed, uh, as I mentioned earlier, this has been designed using the Google images. We have used the Google API to fetch various images, right? So we have exhaustively uh, exhaustively fetched more than 1,000 images. uh, we have passed those 1,000 images, more than 1,000 images in fact, to some sort of the manual labeling. So the manual labeling, I would say, was the very tedious task, right? So that was not
Okay.
straightforward. We normally in the standard labeling task or in the annotations, what we normally do is we create some sort of the rectangles or the square bounding box. But this was no more into the bounding box, right? So this shape could be anything, right? So when we are, let's say, looking into the tree could be of any shape, right? So this is
Yeah.
completely random. So we have to exactly create and actually exactly annotate the labels in the exact random manner. And we have to create those labels in a very precise order, right? So that was a very very tedious, and I would say the very manual, effort driven task. And
Right.
once we were done with that, then we used our pre-processing along with the augmentation techniques, I mean, to enhance the data volume. So once we had the significant data volume, then basically we pass this model to the blend of the FPN and the point trend algorithm to check this model. So this model basically has been uh, I mean, this successfully captures the the buildings, roads, greenery, right? So I mean, along with the utilities. So this also, I mean, this captures certain classes which have been predefined. But now we are also, I mean, we are also thinking to, I mean, thinking to enhance this application to some other classes. But and in fact, as I mentioned earlier, this is very generic and can be implemented for any other classes as well, right? So I would say I would say, in terms of the the training of the model, right, which was very sophisticated, and we have used our internal GPU clusters to train our model, and it took us basically for 3 weeks to train these models, train as well as to fine tune this model, right? So the first cut of the model we got, I mean, once the data was available, the first cut of the model we got in 3 to 4 days of time. And then basically we spent more extra time to understand the accuracy, to improving the accuracy, right? And then basically it went into the lot of optimizations as well as the lot of feedback, right? And then basically we end up having this model in 3 to 4 weeks of time, right? And to do that, basically we leverage we leverage the cloud infrastructure as well as our on-prem infrastructure, right? So I think that was the overall infrastructure as well as the backend application, backend module that we used for this such a sophisticated platform.
Okay, absolutely. So I think now that you've explained all of it so concisely, Param, I think maybe the next logical question which would come into place is what would be the real world applications of telescope? Like what are the industries that stand to benefit
Yeah,
from
yeah,
all these features that telescope has?
sure. So overall, in terms of the applicability, or in terms of the uses wise, there are telescope can be used across industries, right? It could be used in the insurance space for the risk assessment. It can also be used for agriculture, for the proper resource planning, for the yield predictions, for the proper resource planning. It can also be used by the real estate or by the government agencies to understand if there is any illegal construction, or if the feasibility of constructing any building, right? If I mean, if somebody, or if a real estate company wants to do some feasibility analysis, right, before starting a construction, right, then it becomes very very critical basically for them to analyze the I mean, analyze the quality of the land, right? If for
Right.
example, if you are a power distribution company, or if you are, let's say, a telecom company, right? You want to erect your network towers, right? So it becomes very I mean, critical for you to understand the area in terms of the land quality, right, as well as in terms of the population density, right? So you want to erect the tower, you want to create buildings in the areas where you find that people living density is high, right? Those were some of the industries. Along with that, I think the oil and gas industry is also another industry uh, the defense, right, the defense forces are also utilizing such image segmentation techniques, right? So there are variety of industries where this application, this telescope can be utilized.
Okay. Okay, understood.
Yeah.
So I think from this vast list that you mentioned, Param, I think what really jumped out at me was the insurance and agriculture industries, because I mean they are some of the biggest industries that we have, at least in India right now. So maybe you could go into a little more detail about how Telescope stands to benefit these industries.
Sure. So, so to answer your first questions, to cover your first industry, insurance space. So, so recently we had a conversation with one of our clients, uh, and we showcased this application, and it really, I mean, surprised them the kind of the results that it gets, and it can help to automate some of their flows, right? The key part was basically for any insurance companies, as they want to insure the different properties, the different properties, right? They have to, the properties it could be the buildings, it could be some vehicles, or it could be anything, right? Their end goal is basically they have to insure, their business is basically they have to insure certain properties, right? So now to insure those properties, and the premium basically depends on the quality of the property, right? So they have to decide the premium, and the premium is basically dependent on the quality of the buildings, of the quality of the properties, right? So that's where basically the risk assessment is very predominant for the insurance company, right? So that is where we have, I mean, they can use this application in a variety of ways, right, where it can help them to identify the risk associated with these properties, right? So we can help them to identify, right, whether the property lies within the city, outside the city, how much vegetation, how much vegetation, or uh, how much, let's say, the water bodies are around a certain area, right? If the water bodies are more around a certain area, there is high likely that the property might have certain consequences in the near future, right? So there might be highly likelihood, right? So so that could be the one scenario. So another scenario could be, let's say that you have identified a building, right? And then you want to access the risk, you have to check the quality of the building, right? How many floors that building has, what is the quality of the construction, how many people are living in that building. So many factors get into that, right? So to do that, basically, the insurance company have to evaluate, have to do that sort of risk analysis, and which is very very complicated manually, and this is where the solution can help them, right? In terms of the agriculture, in terms of the agriculture, for the government agencies, for the various corporate houses who are running big farms, right? We have come across some clients who are working in that kind of setup, right? They have huge farm base, and now their problem is basically they don't know how to how to check the disease of the various plants, right? So the plants are normally prone to certain disease. So what they can what I mean, they want to utilize is basically what are all the plants who are prone to certain disease, or in case if there is a disease, then how to take the certain actions, right? So that could be one potential area. Another potential area in the agriculture space could be for the government agencies, where they have to do the proper planning, right? So for that, they want to really assess that how much area of the land is covered for a certain crop, right? So that, and during the harvesting season, they can plan certain resources, right? So uh, at the end of the day, when the grain comes to the market, they have to have certain warehouses in place, right? So all this infrastructure, all that management that needs to be done, that needs to be think through, I mean, prior to the harvesting season. So it becomes very critical for the government agencies, for the various corporate houses, right? So I think, uh, along with the insurance and and the agriculture, I also would like to maybe take you through one or the two use cases from other
Sure.
industries as well.
Yeah.
Right. So these days, we know, in especially in the time of globalization, the oil and energy companies, they are transporting fuels, gases through the big pipelines, right? So that, I mean, so sometimes, what it happens is, because of some issues, some problems, the pipeline gets leaked, or sometimes there is some oil slippage, right?
Yeah.
So that becomes that is not environmental friendly, right? If the oil gets leakage, or maybe if there is leakage anywhere, so that overall that is not environmental friendly. So so and it is I mean, for manually sometimes it takes basically weeks or days to access the problem, right? Then I mean, such kind of tools can help them to identify that where exactly the pipe is leaked, where exactly the oil is slipping spilling, right? So that sort of use cases also can be implemented. Defense forces, we all know that, I mean, these are some mission critical I mean problems, and where it becomes very critical for the defense forces to use this images, I mean the satellite images data, and this is where they can also be used, right? So along with that, there are plenty of other use cases. We can have an exhaustive list, but I think these were some of the high level use cases which can be leveraged in these industries.
Absolutely. So I think Param, from one of the things that you were saying from the insurance section, at least how for real estate agencies they assess the risk of areas. So I think, I mean, given the recent flooding that was in Bangalore, I think it would really help urban planning authorities to be able to plan and assess better, at least in the future, given
Exactly.
that this flooding has been increasing recently. So I think maybe something like telescope could really tie in there, which
Correct, correct.
kind of brings me to my next question, as in you've given this a whole host of use cases that
Yeah.
telescope can be used for. Now I just wanted to check in with you, can telescope as a solution be adapted to work for other use cases that you don't have in your list currently?
Exactly. So correct. So let me come back to my beginning of the conversation, where I was talking about the generalization of this platform, right? So right in the beginning, I talked about that this platform is completely generic, and it can be easily enhanced to any specific use cases, right? So there can be the variety of problems, there can be variety of customization required by the different clients, right? That could be the data sources. They want this application to be integrated with the different data sources, right? So they could have the different altogether the different use cases which they want to solve, or they also could want to have some specific visualization in place, right? So there can be the different ways this can be customized, right? And the architecture that on which we have built this application is completely configurable, completely generalized, right? And it can be easily configurable, it can be easily customizable to whatever extent, to I mean to the whatever use case the people want to solve, right? It is just a matter of the discussion that we can have. I mean, we can come on board, we can discuss, and then definitely I assure you that we can implement, and this application can support most of your use cases.
Right, absolutely. So now, given this adaptability of telescope, Param, are there any future enhancements that you've already got planned, like which you had maybe envisioned in the beginning, but now you've seen that and you've
Yeah.
got it in the pipeline?
I think that is a very very relevant question.
Yeah.
So in fact, uh, from the last few months, we are in discussion with various clients, and every day, almost every day, we come across a solution or come across a problem statement which we are going to integrate in this application, right? So that is something that we have something in plans. So so for example, the one use case that we were talking about just some time back was the risk assessment for insurance companies, right? So for the risk insurance, so now one problem statement which came to us was, let's say that we have identified a building, and now they want to, I mean, to have that risk analysis, to have the risk profile of that building. It becomes very critical for them to understand the how old the building is, how many floors that building has, right? uh, Whether I mean the quality of the building, right? What is the quality of the building, right? Is it prone, or the area where it is situated, is it prone to some snowfall, or is it prone to some sort of the water bodies around its proximity, right? So that sort of the problem statement come to us. uh, that is something that we have already started thinking through it. uh, Along with that, there are other use cases, the another use cases which came, which few days back we were researching. uh, so there was another use cases from the Germany, right? So
Okay.
from the Germany, there was a company who was laying down a railway track, right? And the railway track was supposed to pass a forest. Now they have to cut down those trees around to lay down that line, right? So now the problem was they want to cut down the trees till a distance uh, where they are sure that even if the tree falls, that will not get onto the track, that will not fall onto the track, right? So they have to estimate the height of the tree,
Right.
right? So that sort of analysis, so that sort of segmentation, that sort of analysis is really requires this kind of tools. And we are during our client conversation, these problem statements are coming to us, right? So clients are throwing those problems to us, and we are here to help them out. And we all of these problems are basically in our pipeline, and one by one we have started working on these.
Okay, that's
Yeah.
great to hear. So I think, I mean, given the vast number of use cases that you've explained, and even what you've got in your pipeline for the future and everything, I think everybody must want to know how do they get access to Telescope. I mean, how does someone get the access to use this tool?
Yeah. So this tool is very much accessible to almost everyone whosoever wants to access this application, right? They can visit find.ai, right? And they can request for a demo, right? And we will come back with the requested time slots and I mean with the demo, right? We will help you out with all your questions, and then we will also help you out to set up this product on your environment, right? In case if you want to set it up on your environment, or wherever you want. The another option is if you are a AWS customer, right? If you are already have the AWS services, then you can use this application from the AWS marketplace. This application, as I mentioned in the beginning of our conversation, this has been hosted on the AWS marketplace as a SaaS offering. You can easily get it. You just need to register yourself. You just need to uh, enable your services for Telescope, and you would be allowed to use this application, right? So it is easily accessible. You can visit the find.ai, or you can get it access through the AWS.
Okay, okay, got it. I think unfortunately we are running out of time in our session. I see a few questions coming in the chat box, but I mean, I hope we've covered most of the questions. For those of you who didn't find the answers to your questions, make sure you connect with Param on LinkedIn, and I'm sure he'll be more than happy to clear those for you. Thank you so much, Param, for that absolutely insightful session, for running us through, giving us such a comprehensive view of what Telescope can do and all the future amazing things that you've got planned with it. It's been a total absolute pleasure having you on here.
Thank you, Nichelle. My pleasure talking to you.
Absolutely. We hope to
Yeah,
see you soon again, Param.
yeah, sure. Thank
So,
you, and happy to
yeah,
answer if there is any questions.
yeah. So I think that's it. We can wrap it up then. So thank you all for joining us today. Make sure you tune in for all our future LinkedIn sessions. And until then, take care and stay safe.